Hey there, you are on Vectorly, and today we are going to solve a few more problems from work power energy. These are some interesting problems. Just give it a try, and I will be uploading the PDF for the complete work power energy. Just go through it. Okay, the first question is an experimenter throws an ball of mass m is equal to 1 kg vertically upwards with a velocity u of 4 meter per second from the top of a high tower. During the flight of the ball, modulus of the force of air resistance on ball is given by the equation F is equal to kV. Here, k is 0.41 kg per second and v is the speed of the ball. The tower is so high that the ball achieves a constant speed before striking the ground. Find velocity of the ball when its kinetic energy changes most rapidly. Acceleration due to gravity is 10. Let me first put the situation into diagram. So just considering this is my height tower, okay, and I'm throwing a ball out here upwards. So it will go up and it will come down this way. Okay. Now I'm considering as two parts, the first part and the second part. Let me first write this. I'm going to apply two methods. The first method I'm going to do is let's consider the first path in which the velocity, and you just see it, the force of resistance will be always opposite to the direction of velocity. Okay, so since the ball is moving up, the force of resistance in the first part of motion will be downwards, which will be along acceleration due to gravity. Okay, so v is equal to, what is the initial velocity? The initial velocity is u minus g plus kv by m, okay, into t. So what is happening is v equal to u minus gt minus kv by m into t. Now I will continue this here. So I will bring this to the right side and take v common. So what I get is 1 plus kt by m equal to u minus gt. Okay, so velocity v is nothing but u minus gt whole divided by 1 plus kt by m. From this, what can I conclude is, what is the question? When the kinetic energy changes most rapidly. Kinetic energy is proportional to v square, and I will make this equation over here. So kinetic energy is v minus gt by 1 plus kt by m the whole square, and this thing should be changing most rapidly. That would be the point of inflection. Okay, point of inflection should be found. So now this is another method, but finding the point of inflection for this function would be a very lengthy process. So I would suggest another method. That is, what is the rate of change of kinetic energy? It's simply power, right? So power is nothing but force into velocity, right? Considering in the first part of motion, considering the first part of motion, what will happen? What are the forces acting? Kv is acting, and G is acting on the same direction into V. Correct. This is in the first part. Whereas in second part, the power is G minus kV into V. Yeah. Okay. Now we have to maximize this. Correct. So upon differentiating, what you get is, first it gives kV square plus GV, and here it gives GV minus kV square. Upon differentiating this, what you get is 2VK plus G, and over here G minus 2VK. And to find the maximum, we would equate the first derivative to 0. So what we get is, actually the force kV, and this is mg. I forgot to add the mass m. And what I get is 2v k is nothing but minus mg. K it's plus or minus because I'm considering the two cases. So v is nothing but plus or minus mg by 2k. This is the required equation. So the velocity of the ball when the kinetic energy changes most rapidly is plus or minus mg by 2k. This is much more shorter way, correct? This is much more shorter way, and this is a lengthy way. But initially people would start thinking in this direction, but when they ask this kind of when its kinetic energy changes most rapidly, we have to consider the quantities which are involved in it, which are already defined in the physical terms. Question number 2. When a particle passes a point x, y in a force field created by stationary sources, the potential energy of the system associated with the force field is given by the equation U equal to kx by x square plus y square the whole power 3 by 2. If at a position r, the particle is so observed moving perpendicular to r vector. Find the tangential and normal components of acceleration of the particle at this point. Actually, this is a typical question from conservative fields. Let me explain the concept. This is an easy question, but I choose this question to explore this concept. First, potential energy is mainly associated with conservative fields. In conservative fields, what you get is it is path independent. It is path independent in terms if you move from point A to point B in a conservative field, no matter what which is the path, okay, maybe the path this path or something like this, the work done would be same. Okay, the work done would be the potential energy. Example is something like electrostatic force and gravitational force. In gravity, no matter which path the body follows, but we consider the potential energy is the difference between the height multiplied by acceleration due to gravity into mass. That is a change in potential energy, right? So that is what we are speaking as conservative fields. And the important thing is the potential energy function is related with the force by this equation. The force F is nothing but minus negative gradient of potential energy. This symbol is termed as gradient, which you will encounter in your college and all. Okay, now what is this force actually is a vector and gradient results vector from a scalar. So what is this? I am just write it. Gradient is nothing but negative of dou u by dou x. This is partial derivative of potential energy function with respect to x minus partial derivative of potential energy function with respect to y in this. This is the force vector. So, okay, first let's find the force vector over here. So, F vector is nothing but negative of this is the component in I direction. Similarly, the component in j direction is given by first kx by x square plus y square the whole power 5 by 2, okay, into 2y, and where I have to add this 3 by 2 part 2. So this will become plus into j cap. You can verify this into differential. And what next is upon simplifying these things, now the thing I have to put is in points, the r vector, the point at which we are doing our calculations is r naught I cap and r naught j cap, which is r naught comma r naught. So I'm going to substitute it the force at the point r vector, which is minus of k into this will become 2 r naught square the whole power 3 by 2 minus 3 by 2 k. This 2 gets cancelled anyway. 3k into r naught into 2 r naught square whole under root, okay, whole divided by 2 root 2 r naught cube, okay. And the x here would be replaced by again r naught. This is the I cap component plus 3k r naught square whole divided by 2 power 5 by 2 into r naught power 5 j component. So finally the force vector at position vector r vector is negative of, so it become 2 power 3 by 2, which is nothing but 4 root 2, okay. Sorry, this is cut. 2 root 2 k into r naught cube minus 3 root 2 r naught cube whole divided by, this is r naught power 6. Here what I get is 2 root 2 r naught power 6, okay. Take this would become 8 actually. I cap plus 3 by what is this particular thing, which is 4 root 2 r naught cube j cap. 1 by 4 root 2, okay, r naught cube I cap plus 3 by 4 root 2 r naught cube j cap. This is the final force function at that particular point. Now they have given that the object is moving perpendicular to r vector. Let's say from origin we are marking r vector. This is the r vector and this is the particular point. The body is moving perpendicular to it. This is the direction of the velocity. Okay. Now what happens is find the tangential and normal components of acceleration of the particle. Now if you see, let force vector be somewhere in this direction. Now the component of force vector along the normal to the velocity, right? The acceleration component normal is nothing but this is F vector, right? F vector dot r cap, correct? This is the component of force. This is a component of force along the normal direction to velocity divided by mass. Okay. Now what is r cap? So r cap is nothing but I cap plus j cap by root 2 over here. So 1 by 8 r naught cube plus 3 by 8 r naught cube multiplied by 1 by m. So what I get is 1 by 2m into r naught cube. This is acceleration in perpendicular direction. Similarly, we have to take the cross product of r cap and f vector to obtain the acceleration along the direction of velocity. That's it. Okay. Question number 3. A small disk of mass m placed on a plane of inclination theta is cos inverse 0.8 with the horizontal is connected from a nail driven into the plane with the help of a light inextensible cord of length L. Coefficient of friction between the plane and the disk is mu. The disk is held on the plane stretching the cord horizontally as shown in the figure and released. Find maximum speed of the disk and the angular displacement where tensile force in the cord becomes maximum during subsequent motion. First, let's analyze the motion. I am keeping my frame as a plane. Okay. I am considering this as the plane in which out here it is attached. This is the disk. Okay. Now what is the acceleration in along the plane? Along the plane, I'm getting G sine theta works. Okay. Now into the plane. What am I seeing into the plane is G cos theta. Okay. Now this force of friction would be always acting in the direction opposite to the velocity. Correct. So we can't mark here at we can mark at the particular instant, but we can't mark a complete direction for friction. So as the direction of friction keeps changing, work power energy is an efficient way to solve this problem. Let me tell why. If the particular body went till this distance, okay, let the angular displacement be phi. This was this original position, length L. Okay. Now the perpendicular displacement over here is nothing but L sine phi. Correct. Now work done by gravity is nothing but the force mg sine theta is acting in that direction and displacement is L sine phi. Correct. Now what is the work done by friction? The friction will act along this path, right? But the magnitude of this is a kinetic friction, so the magnitude will be same, which is mu times the normal reaction. What is the normal reaction? Mg cos theta into the path traveled is L into phi. Phi should be in radians. Remember. Now these are the only work done, right? So this work done should result in some amount of kinetic energy. We have to find what is it. Mg into L sin phi sin theta. Okay. See, what does friction do? It reduces, it does negative work because the friction direction is this direction, the displacement is along this. So, minus mu cos theta L phi is nothing but V square by 2 into M. That is kinetic energy. I am cancelling this mass. Okay. Now we have to maximize this velocity. Okay. Now I will differentiate both sides. So, what I get is LG. Else we can consider this thing too. This is a shortcut to solve it. Actually, if v square should be v should be maximum, v square should also be maximum. So let's consider. So I'm going to consider v square as k. Okay. So what I get is Lg into sine phi sine theta minus mu cos theta into phi is nothing but k by 2. I have to maximize k. So if I differentiate it, what I get is remember theta is a constant. So cos phi into sin theta minus mu into cos theta should be equal to 0. So what I get is cos phi is mu cos theta whole divided by sin theta, which is mu cot theta. Now, since we have values of theta and mu, we can directly find the angle phi. Okay, by substituting it, we will find the value of 5. 5 is done, and with 5 we can find V2. Okay, what else are they asking in the question? And angular displacement where the tensile force in the cord becomes maximum. This is the second part. Okay, during the motion, the tensile force would be acting. Let me draw a new free body diagram in which this is phi. Okay, the tensile force T is acting in this direction, mg sin theta in this direction. Okay, the force of friction would be acting mu mg into cos theta in this direction. And what about mg? This is phi. When this is phi, this is also phi. And in this direction, what I get is this is mg sin theta. So this is mg sin theta into sin phi in this direction. Okay. Here what I get is mg sin theta into cos phi. Okay. Now the tension force T is T minus mg sin theta sin phi. It's nothing but m v square by L. This is the centripetal force. Okay. So what will we get in v square? So v square, we found the function of v square, right? So we found the function of v square, which is nothing but, let's find write mv square itself. So from I will continue here. T is equal to mg sin theta into sin phi plus 1 by L into, what we get is this 2 will go there, 2 mg into 2 mg L, correct? So what I get is 2 mg L into sin theta sin phi minus mu cos theta phi. Sin theta sin phi minus mu cos theta into phi. Okay. So this t is nothing but L gets cancelled. This 2 mg into sin theta sin phi plus mg into sin theta sin phi, 3 mg into sin theta sin phi minus 2 mg mu into cos theta phi. Okay. Now I have to maximize this. So T max here is, to find T max, we are differentiating it and putting it to 0. So 3 mg into sin theta cos phi. To differentiate the same function, this part would be remaining. So which is equal to 0. So 2 equal to 2 mg into mu cos theta. So what they actually want is cos phi is nothing but 2 by 3 into cot theta. This is the answer for the second part. Okay. Question number 4. This is a previous International Physics Olympiad question, which looks good. This will develop your intuition. Okay. A small block with mass m is placed inside an inverted cone that is rotating about a vertical axis such that the time for one revolution of the cone is t. The walls of the cone make an angle beta with the vertical. The coefficient of static friction between the block and the cone is mu. If the block is at rest at a constant height h above the apex of the cone, what are the maximum and minimum values of t? Okay, let me draw the situation. Let this be the cone. Okay, and there is a block about here, and this particular cone is rotating about an vertical axis. Okay, this is 90-degree, and this is beta. So what this is 90 degrees minus beta. Now what happens is this is revolving in this direction. Let's take. Now this block M is rest relative to this. So why not let's fix the our frame of reference with this one. But we are fixing our frame with an non-inertial rotating frame. So we have to apply some fictitious forces. Here we would apply centrifugal force. There is another force termed as Coriolis force, which will be applied when you see an object from a frame which is rotating, but the object is not in that frame. The object is outside. Let's say you're sitting in a merry-go-round and seeing your father or mother who is standing on the other side. Okay, their motion would look like some curved, right? That is due to this frictious force called Coriolis force. Here, it is not required because you are sitting in a merry-go-round and you are seeing your brother or sister in the same merry-go-round. So here we apply the centrifugal force. Okay, block M. Okay, there are two cases in this. The friction will act upwards or downwards. Okay, first let me mark forces of gravity mg into, here I get cos beta, and here mg into sin beta, and I get normal reaction over here. Here m omega square, when the height is h. Okay, what about this part? See, tan beta is nothing but the required length L by h. So that required length L is nothing but h tan beta, which is the radius of the thing, m omega square L. Okay. Now two cases are there. I will do the first case, you do the second case. What are the two cases means? If omega is more, this would try to pull the particular block upwards. Correct. So the friction would act downwards in order to make it rest in this frame. Okay, that is one kind of case where, let's consider that as case 2, where omega is more and time period is less. So omega is max, time period is min. Okay, in that case, friction would be acting down. Now here, what happens is friction would be acting upwards. Okay, now what people usually write is F is nothing but, they will take the component here. This is 90 degree minus beta. Okay, F is nothing but mg into cos beta. Okay, minus m omega square L into sin beta. This is the correct part. Okay, for the friction, they will write mu into mg sin beta directly. While writing the free body diagram itself, they will write mu into mg into sin beta. But they won't consider the force, the component of the centrifugal force perpendicular to this plane. That is an important point of common mistake. So what they write is, this is a common mistake where people will not consider the component of centrifugal force. So you should not do it. This mistake occurs even to me during my JEE preparation. Okay. Now, what is the friction force? Mu into mg sin beta would be there. Along with this, what I get is m omega square L into cos beta, which is mg cos beta minus m omega square L sin beta. Now, let's group the omega square terms because we need our time period, right? This is the limiting condition. We don't want to find the maximum because this is a maximum case. Okay. What I do is cancel all the m terms. Okay. Mu g into sin beta minus g into cos beta is nothing but minus omega square L into sin beta plus mu cos beta. Let me cancel the negative parts. So what I get is g by L into cos beta minus mu sin beta. Okay, whole divided by sin beta plus mu cos beta, which is nothing but omega squared. So let's make this fancy. Why these many writings? Let me divide by cos beta. So what I get is G by L into 1 minus mu tan beta whole divided by tan beta plus mu. This works, right? Equal to omega square. Upon taking square root, what I get is under root G by L into 1 minus mu tan beta whole divided by mu plus tan beta, which is omega. Now, in our case, what are we calculating? The T max, right? So T max would be 2 pi by omega. So 2 pi into under root L by G mu plus tan beta whole divided by 1 minus mu into tan beta. This works. This is the maximum time period. Similarly, you have to calculate the minimum time period using the case 2. Do comment your suggestions and requests from your side. Let me do it. Thank you for watching this video. Kindly support our channel by subscribing and commenting your thoughts. Thank you.